Welcome to our channel Learn Easy with Sukan. I am Sukan and have pursued my master's degree in the Department of Electronics and Communication Engineering. Right from the beginning, DSP have always been my favorite subject. Usually, everyone thinks that DSP is the toughest paper and often calls it as a degree stopping paper. But believe me friends, thinking like that is totally a myth. DSP is not so tough as you think. The reason for people to have such a thought is that it deals with many formulas and calculations. But if we have a clear knowledge and idea, we can crack it very easily, friends. So, let me teach you the secret mantras and will make you feel that DSP is a degree scoring paper by the videos posted in our channel. The entire topics are to be covered as 5 separate units with many subtopics in each unit. And at the end of each and every video, tips and tricks for the respective topics are to be provided. So friends, before proceeding, let us have a proper mindset which is very important for any success. So let us follow the C cube mantra friends. The first C stands for confidence. First of all, have full confidence and hope on yourself that you can do it. And the next C stands for concentration. Have full focus on the subject without any sort of distractions. And the next C is constant practice. Yes friends, do practice daily for having a consistent result. Hence, to learn DCP easily with short and crispy videos that has simple explanations, do not forget to like, share and subscribe our channel. Now, let us have a short intro about fundamentals of DSP and its applications. Introduction to DSP. In this session, we will learn about what is a signal, what is signal processing, what is continuous and discrete signal, what is continuous and discrete system, what are the digital and discrete signal, what is digital processing, and the real-time applications of DSP. What is a signal? A signal is a function that conveys information about a phenomenon. It describes how a physical quantity varies with respect to change in time. Generally, a series of information can be called as a signal. Now, what is signal processing? The signals obtained from various sources are raw in nature. The process of converting those raw signals to the required format by means of applying the mathematical algorithms is said to be signal processing. Broadly, the signals are classified as two types. One is the continuous signal, other is the discrete signal. What is continuous signal? The signals having continuously defined values is called as continuous signal. For example, in this diagram, let us consider the time instant between 2 and 3. The time interval t can be divided as 0.2 or 0.002 or 0.00002 etc. So this implies there are continuous and infinite number of values between the range of 2 and 3 seconds. So hence these signals are said to be continuous. Whereas in the case of discrete signal, the values exist only for the discrete time instance. In this example, there are no values between the range 2 and 3 and the 2 and 3 has an amplitude of 1 volt each. The values exist only for a particular time instant for these discrete signals. What are continuous and discrete systems? A system that processes continuous signal is said to be the continuous system. The change of state occurs continuously for all time instants in this system. A discrete system is a system that processes the discrete signal and gives the output. In this system, the change of state occurs at a particular definite time instant. Now let us learn about digital and discrete signal. A digital signal has only two different values, 0 and 1, and have both the time and amplitude to be discrete in nature. Whereas a discrete signal, it has different values and has discrete time period but continuous amplitude. For example, if you consider the graph under the digital signals, it has only two values 0 and 1 for every time instant. But for the graph under the discrete signals, the values are different. It is having 0, it has 1, it has 2 and it has -1 and so on. So from these two graphs we can see digital signal has discrete time and amplitude, whereas the discrete signal has continuous amplitude but discrete time. So this is the difference between digital and discrete signal. Hence, the digital signal processing is the process of analyzing and modifying a digital signal to optimize or improve its efficiency or performance and to obtain the necessary state of signal. Some of the real-time applications of DSP are the sorts of integrated circuits like FPGA, ASICs that are designed by using the semiconductors. Next is speech coding and transmission in mobile communications. And next is weather forecasting and seismic data processing. This is done by it continuously records the weather data and process them to predict the occurrence in the future. The next is analysis and control of industrial processes. Almost many industries make use of this DSP as applications in order to bring their better products out. And the next is in medical field for MRI scans by reconstructing and viewing the images. The next is MP3 compression, computer graphics, audio crossovers and equalization and audio effects. It uses DSP in the process of converting of the analog to digital form for processing and again to digital to analog at the receiver end, that uses several techniques of the DSP. And the next is radar and sonar. This is to find the position and the exact place of the flights. And the next is the image processing. In image processing, for editing and data retrievals of images used. For example, the best example, a well-known example is the Photoshop software or whatever, all the photo editing apps. And in the below flow diagram, the process of the edge detection of an RGB image, that is red, green, blue image is shown. So that involves 3D to 2D conversion, where the normalization and the pixel intensity distribution will give you the grayscale image. And next is the high pass filter. The usage of high pass filter will help us to retain the edge information of the image, so that we can get the edge detected image in the next step. And high pass is one of the thing we study in DSP. But the proper edge is not detected here. In order to get the edge information very accurately, they go for the wavelet techniques. In the wavelet techniques, both the high pass filter and the low pass filter are used. They will it's not neglecting, rather than taking the high pass filter result, they take the low pass filter result of the first stage and again apply the high pass filter and low pass filter for that stage, and this process goes on repeating, and finally after some n number of stages they get the enhanced edge detection of the image. So friends, hope you had an idea of DSP fundamentals and applications. With this, let us step into the units of DSP in the upcoming videos. Until then, take care friends.